Hello, this is question 12 on your mixed exercise 14. So the table below gives the surface area S and the volume V of 5 different spheres to one decimal place. So this is the surface area, this is the volume. And given that S is A, V, B, where A and B are constants, and I think there is a mistake here because we should write V in terms of S. So I think the formula is the other way around. So it's V is A S to the power B. It could be done in more recent versions of the book. They have changed. So if you have something different, I think it makes more sense. So that log S is log A plus B log V, and again I think this should be the other way around. Yeah. How will we show that? Regardless of this being the question like this or like this, we are going to take logs. Yeah. So we have for A, if our expression is V A S B, when we take logs, we have log V is log A S to the power of B. And using the properties of the logs, I have a product, so I can write this as log V is log A plus log S to the power of B. And again, using the properties of the logs, this B can go to the front. So I could have log V equals log A plus B log S. Yeah, and that could be the expression. You could do the same, exactly the same with this one. Copy and complete the table of values of log S and log V, giving your answer to 2 decimal places. So we just have to find with the calculator the values of log to the base 10 of these numbers and write them here to 2 decimal places, and the same with the V numbers. Yeah, I just have it so we don't waste the time doing that. Plot a graph of log V against log S. That's why I think this is going to be. So log V is the Y, this one is the X. Yeah, so my expression is going to be log V equal to something when I find the line of best fit. Yeah, that's why I think this is the other way around. Again, you represent your axis. In the horizontal axis is the log S, in the vertical axis log V. Your values go from 0 to almost 3 in both occasions, so that's what I have in the scale. And then when you represent the points, you see that they are very, very close to a straight line, really. Yeah, so it's a very linear connection. And then you draw a line of best fit. It's going to be slightly different for everyone. Because we are not using formulae or anything like that. We are just representing the line of best fit. And then D, use your graph to confirm that B is 1.5 and estimate the value of A. So how do we do that? If we look at this equation here, this expression here, this is a straight line. Yeah, so log V is what I have in the Y, log S is what I have in the Y, and then I have another constant and another constant. So I have Y equal C plus X, which is a straight line, really. This one is going to be the gradient because it's multiplying my X, if you want to call it X. And this one is my Y-intercept, and that's what I have to find. So B is going to be the gradient of that line. To find the gradient of the line, I can get 2 points of the line and do the difference in Y, difference in X. But as I have some points and the line is quite passing the points almost, I'm going to use the points here. Yeah, so I can take, for example, the last one and the first one. Yeah, so I'm going to do difference in Y is going to be 2.72 minus 0.86 divided by 2.5 minus 1.26, and this is 1.5. Yeah, and that's what they ask us to prove. Then estimate the value of A. A, this is going to be the y-intercept of this line. Yeah, so I could extend it and try to guess more or less, but it's a bit difficult with the scale. So what I'm going to do is just write the equation of the line and then use it from there. So if I write the equation of the line, I'm going to do y minus the y of 1 point, just because I have already the gradient, x minus the x of 1 point. So that means y minus, and I'm going to choose any point really. Yeah, so I can get, for example, this one or this one in the middle. So y minus 205 is going to be the gradient 1.5 x minus 205, and from here I'm going to get the y-intercept. Yeah, so when I expand this bracket and I take this to the other side, I will have y is equal to 1.5x, and then I have 205 positive and 1.5 multiplied by 205 negative minus 1.5 times 205, and this is the y-intercept. Yeah, and this is going to be log a, because this is not really y, this is log v, and this is not really x, is log s. We are working with this line. This is the line that we have represented. Yeah, and this value here is 103, so I can say that log a is 103, and that means that a is 10 to the power, sorry, minus 1.3 because it's negative, minus 103, and this is 0.0933 something, so I'm going to round the 2 decimal places, for example, because they asked me to round to 2 decimal places. This value, it seems fair. Yeah. Sorry, to one significant figure. So one significant figure is anyway the same. One significant figure. I didn't read that. Yeah. And that's all with this question.